Before you design an earthing system, you need to know what you are designing it for, and that starts with the soil. In this video, you will learn how to measure it. But why should you listen to us? At Axis, we have been manufacturing a wide range of earthing and lightning protection solutions for more than 30 years. You will find our products installed in solar plants, utility scale applications, substations, control panels, switch gears, and many more. Let's start with the basics. Soil resistivity is a measure of how strongly soil resists the flow of electrical current. It is measured in ohm meters and can vary widely from site to site. There are several methods used to measure soil resistivity. However, IS 3043 recommends Wenner's Four Electrode Method, and that is what we will be covering today. Now, let's start with the measurement procedure. You will need 4 auxiliary electrodes for this test. The 2 outer electrodes carry the current. Call them C1 and C2. The 2 inner electrodes measure the voltage. Call them P1 and P2. All 4 are temporary test spikes driven into the ground. Note: soil resistivity changes with moisture content. A wet soil gives you an optimistic reading. To get conservative results, the kind that lead to a reliable earthing design, IS 3043 recommends conducting this test during the dry winter or dry summer season. Step 1. Choose your test location and direction. The number of test locations depends on the size and type of your site. For example, substations require at least 8 test directions from the center of the site, and for transmission lines, measurements are taken along the direction of the line approximately once every 4 kilometers. In this video, we are demonstrating the resistivity measurement procedure at our manufacturing facility. Step 2. Set up your electrode layout. At the selected test site, drive all 4 electrodes into the ground in a straight line at equal intervals. The depth of each electrode in the ground should be between 10 and 15 centimeters. You choose the spacing between each electrode, and this spacing is what determines the depth of soil you are measuring. Step 3. Connect your resistivity meter. Open the link between terminals P1 and C1 on the instrument. Connect the 4 electrodes to the respective terminals on the meter as shown in figure 87 of IS 3043. C1 and C2 carry the test current. P1 and P2 measure the voltage drop. Step 4. Take your reading. Select an appropriate range on the instrument to get a clear reading, avoiding the 2 ends of the scale. Record the resistance value R shown on the meter. Step 5. Calculate resistivity. To calculate the resistivity, follow the formula given in the standard, which is Step 6. Check for soil uniformity. Repeat the test at the same location with increasing electrode spacings from 0.5 meters up to 250 meters in steps of 0.5, 1, 2, 3, 5, 10, 15, 25 and 15 meters, or up to the boundary of the site. If the resistivity readings across all spacings stay within plus or minus 30% of each other, the soil is considered uniform. If the variation is greater, the soil is non-uniform, and a 2-layer or multi-layer model will be needed for your design. I hope you now have a clear understanding of how to measure soil resistivity. At Axis, we have a team of 50+ engineers who design, install and test earthing and lightning protection systems as per your requirement. Our products have been used in substations, data centers, factories, and even in everyday residential and commercial buildings. If you found this video helpful, please give it a like and subscribe to our channel for more insightful content on electrical engineering. Before you move on to another video, Remember, nothing can compensate for inadequate installation. Watch this video right here to learn the correct installation procedure for earthing.